This is video 24. In this part, we present a version of the window movie lemma specific to our setting. Note that some technical details are omitted. They are available on the article version of this proof. Consider a finite simple path assembly P. This path assembly is producible by a deterministic tile assembly system. The seed in is black. Consider an integer h in the window WH. This window is in gray and its direction is 0-1. Consider the movie M of the path assembly P of height h. In this example, this movie is made of 7 output glues. These output glues are in red. Consider a second integer h prime. We suppose that h prime is strictly larger than h. Consider the window WH prime. This window is also in gray. Consider that the movie M prime of P of height h prime. This movie is also made of 7 output glues. In fact, we suppose that these two movies are identical up to translation by a vector W. Here the vector W is equal to 10, 4. Moreover, the translation of the window WH by the vector W is the window WH prime. Consider the right side of the window WH prime, that is to say the graph G2H prime plus 1. This graph is hatched. Also, consider the restriction of the path assembly P to this graph. Consider the left side of the window WH. Here, the window WH is not included in its left side. That is to say, we consider the graph G2H plus 2. This graph is hatched. Also consider the restriction of the path assembly P to this graph. Let's translate these tiles by the vector W. We obtain the following set of tiles. These tiles belong to the left side of WH prime. Here, the window WH prime is not included in its left side. That is to say, we consider the graph G2H prime plus 2. This graph is hatched. Now let's glue these tiles with the restriction of the path assembly P to the graph G2H prime plus 1. The window movie lemma states that this set of tiles is an assembly called P1 which is producible by the tile assembly system. The window movie lemma is more general but we only need it in this setting. Also remark that the window of height h and h prime of this new assembly are identical to the ones of the path assembly P. Then the window movie lemma can be applied again. Consider the restriction of the assembly P1 to the graph G2H plus 2. Let's translate these tiles by the vector W. And let's glue these tiles to the restriction of the path assembly P to the graph G2H prime plus 1. We obtain a new assembly called P2. An infinite sequence of assemblies can be generated by using the window movie lemma. Thus this lemma allows us to pump the part of an assembly which is between two windows. But the statement of the window movie lemma does not allow us to pump a segment of a path assembly. Nevertheless, we now prove that this infinite sequence of assembly can be used to find a pumpable segment in the path assembly P. Consider the path assembly P. Consider the graph G2H plus 2. This graph is hatched. We're looking for a candidate segment of P of direction W which belongs to this area. Consider the segment of P which starts after the output glue M1 and ends after the output glue M'1. This segment is in gray and its direction is W. In this example, this segment of P does not belong to the hashed area. Thus this segment contains the output glue M2. Then we can consider the segment of P which starts after the output glue M2 and ends after the output glue M'2. This segment is in gray and its direction is W. In this example, this segment of P does not belong to the hashed area. Then this segment contains the output glue M3. Then we can consider the segment of P which starts after the output glue M3 and ends after the output glue M'3. This segment is in gray and its direction is W. This segment of P belongs to the hashed area. With this reasoning, it is always possible to find such a segment. Now, remark that the translation of this segment by the vector W is subassembly of the assembly P1. Also, the translation of this segment by the vector 2w is subassembly of the assembly P2. Then by iterating this reasoning, and since the tile assembly system is deterministic, the segment in gray is pumpable. Note that the extension of this segment does not appear in assembly generated by the window movie lemma, but by putting together different parts of these assemblies we can assemble the extension of the candidate segment in gray. Now, we give a more practical statement of the window movie lemma. Consider the example of the previous video. We use a vector v of coordinates 5, 3 and we consider the window of height 0. This window is in gray. The period p of this window is 8. Consider a period of this window. Now, consider an integer k. We aim to compute how many different movies there exists of a path assembly of width less than k. Then consider a path assembly of width less than k. We can suppose that p starts in between w0 and w8. Then there exists 8 possibilities for the starting point of the path assembly p. Here we suppose that the path assembly p intersects with the window in the hashed segment. Thus in this example, the path assembly p starts at the index 3 of the window w and its width is 10. Since the width of the path assembly is k, then its movie of height 0 contains at most 2k plus 2 output glues. We have drawn the edges which may belong to the movie. Each of these edges has to receive a label. This label is either that they do not belong to the movie or it is a direction and a glue label. Thus there are at most 2t plus 1 different labels where t is the size of the tile set. Now, there are at most 2k plus 2 factorial ways to sort this output glues. Thus we can now bound a number of different windows of width k. Here is the statement of the window movie lemma in our setting. Consider a direction v and a positive integer k. We suppose that for any integer h, the width of the path assembly p for the window wh is bounded by k. Then if p is long enough we can extract a large number of movies. Among these movies, we remove some the one which can contain some output glues of the seed, and we look for 2 movies identical up to translation. Some technical details are omitted and available on the article. Note that this version of the window movie lemma does not use output glues or movies. It only requires to have a long enough path assembly and to bound the width of this path for all the windows obtained by a discrete line of direction v. Thus from now on, we will not use output glues or movies anymore.